Welcome to Oryx Learning. Today's lesson is on Unit 3, Equations in Two Variables, Lesson 1, Constant Rate of Change. Zara is trying to improve the performance of her car. She records how fast her car goes over a time period of 40 seconds. The results are shown in the table. Compare the change in feet to the change in time. What is her rate of change? If you'd like to know the answer to this problem, we'll revisit it at the end. Linear relationships. Relationships that have straight line graphs are called linear relationships. The rate of change between any 2 points in a linear relationship is the same or constant. A linear relationship has a constant rate of change. For example, if you look at the chart, the y values go up by 3 each time, from 0 to 3, 3 to 6, 6 to 9, and 9 to 12. And the x values go up by 1 each time, from 0 to 1, 1 to 2, 2 to 3, and 3 to 4. Therefore, the rate of change is 3 over 1, or just 3. It's constant for each value. A proportional linear relationship is a special type of linear relationship. Two quantities A and B have a proportional linear relationship if they have the two following qualities. First, they must have a constant ratio, B over A, which makes it proportional. Second, they must have a constant rate of change, the change in B over the change in A, which makes it linear. So remember, a linear relationship is a straight line relationship that has a constant rate of change. A proportional linear relationship not only has the constant rate of change, but also a constant ratio, B over A. Evaluate the expression -4 minus 7 divided by 5 minus 2. Select the correct answer choice below. In the numerator, on the top of the fraction, -4 minus 7 is -11. In the denominator, or the bottom of the fraction, 5 minus 2 is 3. So our answer is -11 thirds. Does the data in the graph have a linear relationship? Select the correct answer. If you look at the points on the graph below, we can see that a straight line would go through 2 of the points, but not all 3. If a straight line does not hit all 3 points, then the data is not linear. So the correct answer is no. Does the data shown in the table below have a linear relationship? If yes, find the constant rate of change. So here, if we look at the time goes from 1 to 2, 2 to 3, 3 to 4, increasing by 1 each time. The rainfall amount in centimeters goes from 2 to 4, 4 to 6, and 6 to 8, increasing by 2 each time. So it looks to me like they have a constant rate of change. And that constant rate of change is the change in rainfall over the change in time, which would be 2 over 1, or 2 centimeters per hour. Use the table below to determine if there is a proportional linear relationship between the given quantities. State the rate of change. So in this one, for proportional linear relationship, we have to make sure that it not only has a constant ratio, but it also has a constant rate of change. So in this case, if we look, the temperature over time, 5 over 3, 0 over 6, -5 over 9, and -10 over 12, those values are not the same, therefore it's not proportional. However, we can also ask, is it linear? If it's linear, we can look at the rate of change. So the time increases by 3, the temperature increases or decreases by 5. So if it's decreasing, it's going to be negative. So -5 over 3 degrees Celsius per hour. The degrees Celsius is decreasing by 5. The time is increasing by 3, So it's negative 5 over 3 degrees Celsius per hour. So this one is linear, but it is not a proportional linear relationship. Jim measures the height of a sunflower and records the heights. Graph the data, and then, if the relationship is linear, find the constant rate of change. So first we're going to graph the sunflower heights. The days will be our x value, the heights will be our y value. So we'll go over to the coordinate 3, 2, and place a point, 6, 4, place another point, and then 9, 6, and 8, 12, graphing all of the points from the table. Now we can look at how much the days increase by how much the heights increase. So our day goes from 3 to 6, which is an increase of 3, and our height increases from 2 to 4, which is an increase of 2. So we have a slope or a rate of change of 2 over 3. Right, we can do this for each of the points as well. From 6 to 9, it goes up by 3. From 4 to 6, it goes up by 2. So that rate of change is also 2 over 3. And for the last one, from 9 to 12 and 6 to 8, has the same constant rate of change of 2/3. So it is linear, and the rate of change is 2/3. So let's take another look at Zara's car. What's the rate of change? So if we look at the table, we can see that the change in y is from 0 to 350, so 350 minus 0. And the change in x, 10 minus 0, gives us 350 over 10, or 35 feet per second. Right? As the y increases by 350 feet, the time increases by 10 seconds. And again, rate of change in y over change in x, 350 divided by 10 gives us 35 feet per second. So to review linear relationships versus proportional linear relationships, relationships that have straight line graphs are called linear relationships. Linear relationships have a straight line graph. The rate of change between any 2 points in a linear relationship is the same or constant, and that's called the constant rate of change. In order to be proportional, it not only has to have that constant rate of change, but it also has to have a constant ratio, the b over a, which makes it proportional. That is our lesson for today. Thank you for joining us.